Back here with number 3. So the setup for number 3 says the graph of f consisting of 3 line segments and a quarter of a circle is shown above. Let g be the function defined by g of x equals 1 to x of f of t dt. So first thing we need to figure out is who's who. So if I were to take the derivative of g, you recall that when I take the derivative of an integral, that the derivative and the integral kind of erase each other, and this x replaces here. So that means that g prime of x equals f of x, which means if I was to say who's the function and who's the derivative, the function is g and the derivative is f, because f is literally equal to g's derivative. So this function they've called f, I could call g prime. So part A says find the average rate of change of g from negative x to x equals -5 to x equals 5. So average, there's that word again. We're either doing average slope or average value. This is average slope. So I need a point -5 something and a point 5 something. So I have to find g of -5. G of -5 is the integral from 1 to -5. G is just a function of x. So if I plug a -5 here, I plug 1 there. I don't want to do the integral from 1 to -5. It makes me confused thinking about it. So I'm going to flip it around from -5 to 1. But I have to put a negative sign in front of it. So I'm going to go up here and try to figure out this part, and then I'll put a negative in. So I'm going to try to find this area. So right there is a 3 by 4 triangle. Cut that in half, I get 12. This entire circle here would have an area of 4 pi, because it's got a radius of 2, pi r squared. So this will just have an area of pi. And then this is a 1 by 2, so that'll have an area of 1. This 12 should have been cut in half into a 6. So I get 7 plus pi for this. So -5, 7 plus pi. And then if I plug a 5 in, I need to find g of 5, which would be the integral from 1 to 5 of f of x. No need to flip this one around. That 7 plus pi would have all been negative, so it would have been -7 minus pi. So I just kind of flipped it around in my head, so I get that 7 plus pi there. So sorry about that. G of 5 is integral from 1 to 5. So from 1 to 3 is a 2 by 4, so that would be cut in half as 4. And then this is just 8 blocks, so that's an 8, so that's a total of 12. So I have these two, so I'm going to take 12 and subtract 7 plus pi on top, and on bottom I'm going to take 5 and subtract -5, so I get 5 minus pi over 10 will be the slope, the average rate of change between -5 and 5. This is one of the instances where I want you to keep in mind that A is not always the easiest part. In fact, on this problem, A is the hardest part, in my opinion. Says find the instantaneous rate of change of g. Well, we happen to know this picture represents the instantaneous rate of change of g, so I just go to the point at 3. At 3, which looks to be a 4. So that means g prime of x, or g prime of 3, is equal to 4. Nice and simple. Instantaneous rate of change is just g prime. G prime is that f graph up there. Next problem says, on what open intervals, if any, is g concave up? So concave up is code for g double prime positive. And this is a picture of g prime, so g double prime will be the slope. Positive slopes occur from -5 to -2, and again from 0 to 3. So that'll be my answer there. So I'll go -5 to -2, and 0 to 3. And they ask for justification. I'm not going to write this out to take your time, but I would say these are all the places where g double prime, where the slope of g prime is positive. D says, find all x values on the interval at which g has a critical point. Calculate each as a local min, local max, or neither. This is a picture of g's derivative, so critical points, there's one right there and one right there. This is neither, because f, or g prime, goes from negative to 0 back to negative, and this is a min because g prime goes from negative to positive. We would say all of those things and get all those points. Again, you can look at the score guide on the actual document. All right, guys, I'll be back for number 4 in a bit.